All right, so now we got the slope of the tangent at theta equals pi over 6. If we want the equation of the line, all we need is a point to go with our slope, so we can use point slope formula. And that's easy to do. We just go x of pi over 6, which is, going back to the original equation because it's x, it's not dx, d theta, or anything like that. It's x. So that is equal to 7 sine pi over 2 cosine pi over 6. You can do that without a calculator. Use your unit circle. You get 7 square root 3 over 2. All right, and then y of pi over 6 is 7 sine of pi over 2 times sine of pi over 6, and that one's just 7 over 2. All right, so that's our x of theta, our y of theta. So the equation of the line tangent, the equation of the tangent at theta equals pi over 6, that was a terrible pi, is, I'm squinched down to the bottom of the page, y minus 7 over 2 equals negative square root 3 x minus 7 square root 3 over 2, right? Y minus y1 equals m x minus x1. Okay, that's that equation. So here's this lovely graph that we've been looking at. We've been looking at all kinds of properties of this graph. We're going to look at more. We're not done yet. And we're looking at the equation at theta equals pi over 6, which is right there, the equation of the tangent line. So wouldn't it be nice if we could graph this line on the calculator so we could see how well it fits? Well, you can, but it's sort of a pain to get, I have a function and polars. It's like not going to mix well. It's possible to do, absolutely not worth the effort. Who's really good, and actually better than the Casio as well, at graphing polars and linears on the same graph is our friend Desmos. So Desmos does that really well, and that's who we're going to turn to now. So here's our graph that we've been talking about for so long, and I've written in here the tangent line that we just came up with, y minus 3.5, so you don't even have to solve it for y. Desmos is so great that way. So this is polar. By the way, to do polar graphs in Desmos, all you do is use r and theta instead of x and y, and it knows that it's polar, makes a nice polar graph on a nice rectangular grid. And then we throw in the equation line we just calculated. There it is. Look at that nice equation line, how it sits so, the equation of the tangent, that tangent line sits in there so nice. All right. So we know we did the tangent line correctly. Okay, that's that one. That's finding an equation to this guy. So the next thing we're going to look at is we're going to look at, that was awkward. I'm trying to do some page juggling here, and it's working more against me than for me. I think we're on page 558. Yes, page 558. Let's throw some light on the subject. There we go. Page 558, number 41. So in the book, they had you find a few of these. We're not finding the full equation of the tangent line. They just want the slope of the tangent. Find the slope of the curve. They really mean the slope of the tangent of the curve at each indicated point. So they only gave you 4 of them. So that's not a whole lot of practice. But they did, like this one has 2 points, so there are 2 slopes. This one has 3 points, so there are 3 slopes. This one has 4 points, so there are 4 slopes to find. But look, that one's 0 and that one's 0, because look at it. All right, so the only interesting ones are the 2, 0, and the 2 pi. So we're going to do the 2 pi one with this function, 2 minus 3 sine theta. All right, so here is r equals 2 minus 3 sine theta, and the point we're going to use is 2 pi. All right, and it's a little bit confusing because for me, I'm accustomed to having my independent variable and then my dependent variable, x, and then y. Y depends on x. It doesn't work that way here. It's r and theta, and the r depends on theta. So it goes dependent variable, independent variable. Sometimes that throws me a little bit. Anyway, we can still find, so the first thing we're going to do is we're going to parametrize this. But by the way, I'm going to show you that we're going to economize immensely on the work by using our calculator. So watch carefully, because this is what I want you to do for the homework. Instead of doing, we're not going to write out all the big old derivatives like we did here. Using the product rule and everything. So get to be a bit of a mess. We'll use technology to fix that. So we know x of theta equals r cosine theta. And And so what we're going to do is we're going to sub the 2 minus 3 sine theta. That's what we always do in these types of problems. We're going to sub that for the r. That way I have an x that depends just on theta and not on r. Can I write the word sine? Probably not. Equals 2 minus 3 sine theta. Not while I'm talking anyway. Times cosine theta. All right, and then y of theta equals r sine theta. So that is, we're still going to substitute for the r, you know, the 2 minus 3 sine theta. So we're going to put 2 minus 3 sine theta. But this time it's sine theta, so it's sine theta. All right, it's always whatever your function is, cosine theta, whatever your function is, sine theta. So that's why it's always going to be a product rule, which is going to be obnoxious in terms of calculating. But we're going to have a way to get around that. So here's where you want to watch what we're going to do. We're going to say, I want dy dx at theta equals pi. That's what this part of the question is asking you for. They're actually asking for 4 different slopes. This is one of them. All right, so I'm going to say that equals dy d theta at theta equals pi over dx d theta at theta equals pi. All right, and then I'm not even going to figure out what those derivatives are. I'm just going to go to my calculator and use math 8. Right, math 8 is a derivative and gives me derivative at a specific point. Got to turn it on first usually. And we'll quit out of the graph here. We'll clear all that because we don't need that. So math 8. So I'm going to put in the derivative. You know, I could leave it with respect to x, but notice how it's d theta, and that's because my calculator is still in polars. I did not take it out of polars. All right, so I can just use that, but it wouldn't matter what the variable is. So my x was 2 minus 3 sine theta. 2 minus 3 sine theta. So parentheses 2 minus 3 sine theta. Close, and it opened one automatically, so I have to close that. And then times cosine theta. Again, it automatically opened a parenthesis here, so I have to close that. Now I should have another close for the derivative, which I do, so close, close. And then I just tell it at theta equals pi, because that's where we're doing it, at theta equals pi. So I just put in second pi, and I hit enter, and I get, okay, I get this. That's weird. It's weird. Okay, but anyway, this is not really negative. We're not going to put this negative 2.999998. Your calculator has made some kind of approximation, and this number is really clearly negative 3. All right, now I want to do the derivative of x with respect to theta. Oh shoot, I know why, because that was what I just did was the x, wasn't it? Because it has the cosine. See the cosine right there? So what I did was dx d theta. So that actually goes down here. I knew something was weird, although that's not it. Now I got to do dy d theta, okay? So here's what else I'm going to take advantage of. The dy d theta is exactly the same as dx d theta, except it has sine instead of cosine. So what I'm going to do is I'm just going to copy this entire line down, and then I'm going to change the cosine to sine, and boom. Now I got negative 1.99, so guess what? That's really negative 2. Negative 2. So that slope is 2/3. And that's it. That's all you have to do. All right? So what you need to write in terms of your justification, you need to write x in terms of theta, y in terms of theta. It's kind of hard to get around writing this and then say what it is. That's really all you need to do those. And you can sort of, you know, check, because they gave you this nice graph. Let's look at the nice graph. Should we look at the nice graph? Does it look like it has a slope of 2/3? Does it look like it goes up 2 and over 3? Yeah, it kind of does. All right. If I had been doing this one and I got 2/3, I would think I'm wrong. If I was doing this one and I got 2/3, I would know I was wrong. Right. But this one looks like it could be 2/3. So that's all you got to do. So for those homework problems. Speaking of which, what are your homework problems? Because I've now sort of given you everything we need to do in our introduction to polars. We've done polar functions, we've done derivatives of polar functions, we've graphed them, and next time we're going to integrate them. All right, but your homework for now is section 10.3. This is your homework. You know, this is going to be posted anyway. I don't know why I write it out here. It's just sort of habit. we're going to do number 1 and 4. And for 11 to 19 odd, I need you to attach a calculator pick for each. Show me what that looks like. And remember to include the name of the shape that you get, like the dimpled limison, my new favorite name. All right. The names appear on page 555 to 557. Those are the names. All right. Also, you're going to do 39 through 42 all, and you're going to turn in your hand plot of r equals 7 sine of 3 theta with delta theta equals pi over 24. All right, so what does that mean? It means I want one of these. All right, you don't have to have anything special on it, just that. All right, there you go. That's your introduction to polar coordinates and your homework. Enjoy.